So today I'm going to be looking at linear relations. So in this unit we've actually only got really two major outcomes. The one is what we're going to do today. We're going to look at how you can take some sort of real world example, or in this case, a pattern, and we're going to do a few things with it. We're going to make a table of values first. We're going to use the table of values to make an equation that describes whatever we're looking at. We're going to test our equation to make sure it's okay, and then we're going to use it to predict either the future or predict some change that'll happen down the line. The last thing that we would want to look at is how we would graph one of these things. And they're all really closely linked. If you can understand that part, the table, the equation, and the graphing, you've got one of the major outcomes for the unit. The other one is going to be, we're going to look at these things, break them down, analyze them. So starting with the one that we have at hand here, which is a typical type of problem, we're given a pattern. So if you look at the pattern, it's asking us to form a table that relates the number of triangles to the drawing number. Okay, so I'm going to make a table. I'm going to have drawing number as my one column on my table, and then my other one is going to be number of triangles. There's always some interpretation with these things. If you look, we've got like a big diamond shape in the middle that leaves us with 4 triangles on the edges. So if the first picture there on the far left, if we make that picture 1, drawing number 1, there's 4 triangles there. Okay. Then if we go over to the one in the middle, you can see that there's the 4 still on the edge from before, except now there's a new 1, 2, 3, 4 in there. So now we're up to 8. Okay. In the last diagram, we've now got the 8 from before, but now we have 4 new ones right in the center. So we've got an extra 4. So in the third one, we now have 12. Now, I just want to stop for a sec. This isn't directly part of the problem, but this is a linear relation. And how can I tell? Well, if you look here for the pattern, it's just going up by 4 each time. So we started at 4, we went to 8, we go from 8 to 12. It's going up by 4 each time. So what we can do here is we can predict if there was the next drawing, the 4th drawing, well, we should add on 4 again. So the next one should be 16. This is a linear relation because it's growing at a constant rate. It's not going 4, 4, 8, 20. It's going 4 plus 4 plus 4 plus 4. It's growing at a constant rate. It could also be decreasing at a constant rate. Okay. And by the way, this is going to give us a straight line when we graph it. So now that I got my data table, I need to form an equation that relates the number of triangles to the drawing number. Well, with what we have here, we have that it's going up by 4 each time. So when I form my equation, I need to define my variables. So for drawing number, I'm going to make x the drawing number. And you guys can use any variables you want. You can use the letter t, z, v, whatever. Number of triangles, I'm going to make y. And these are the standard ones, but you shouldn't be freaked out if you see a question where they're using t for time or like v for velocity. You can use whatever letters you want. So you should have this in front of you. I'm going to erase it and we're going to form an equation out of it, okay? So it goes up by 4 each time. All right, so here's where we got a little bit of guessing to do. We need to come up with something that has y and x in it and goes up by 4 each time. So I'm going to try y equals x plus 4. That's the most simple one. Okay? Now that I have that, I got to test it. All right? You have the data table in front of you. We found that for the first drawing there were 4. So let's try it for drawing 1. So for drawing 1, we had 4 triangles for the first drawing. So for this one, I'm going to go y equals, and it was the first drawing, so it was 1 plus 4. Okay, so then I have y equals 5. All right, if you look at our table, we didn't have 5 on the first drawing, right? We had 4. So there's a problem with our equation here. It immediately doesn't work. So, all right, so that one didn't work. Let's try something else. Let's try y equals 4x. right? So I'm going to try that for triangle 1, or drawing 1. So I'm going to plug, for drawing 1, I'm going to plug a 1 in for x. So I'm going to go y equals 4 times 1. So that gives me y equals 4. Remember, y was the number of triangles. Were there 4 triangles in the first drawing? Yes, so it worked for the first one, but we need to check it for the other one. Sometimes you get a pattern that works for one, but not for the others. So let's try it again. Drawing number 2. So I'm going to plug 2 in now for x. We're going to see what y equals. 4 times 2 is 8. We now get y equals 8. We had 8 for the second drawing in our table, so it worked out again. I'm just going to try it one more time just to make sure it's correct. It looks like it is. I'm going to plug a 3 in, so I get 4 times 3. Putting a 3 in where I see an x, and that gives me 4 times 3 is 12. Yes, that works again. What that's shown me is my equation is correct. So now I've done B, okay? C, I need to use my equation to estimate the number of triangles in the 30th drawing. Okay? So I'm going to erase my checks here. This was just to confirm. 30th drawing. So 30th drawing, again, it's so important that you define your variables, and putting it right in front of you just makes it that much more obvious. So do yourself a favor, define your variables clearly. My drawing number is my x. So if I want the 30th drawing, that means I want to see when x is 30, what is y? How many triangles do I have if I'm on the 30th drawing? Okay? So I'm going to plug 30 in to x. So I'm going to get y equals 4 times 30. And what do I get? Well, 4 times 30 is 120. So there should be 120 triangles on the 30th drawing. Okay? So now I've got A, B, and C. The last one, which drawing would have 68 triangles? So again, I'm going to erase what I have here and start again. It's a new problem. I want to know which drawing would have 68 triangles. So I want to figure out which drawing had 68 triangles. Well, y was the number of triangles. So I'm going to actually plug the 68 in for y. So I'm going to then get 68 is equal to 4x. So in this case, I'm looking for the drawing number. I'm not looking for the number of triangles. All right, so I need to solve for x. I got to divide both sides by 4 to solve this equation, because whatever x is, 4 times that number gives me 68. If I divide both sides by 4, I get x on its own. So I'm going to go 68 divided by 4 is 4x divided by 4. 68 divided by 4 should be, 68 divided by 2 is 34, so 17. So I should get 17 is equal to x. Okay? And now I got to interpret this. I've got all this math and these like symbols written down, but as long as I'm clear with it, I can relate that back to what it actually means. X equal to 17 means that the 17th drawing will give me 68 triangles. Okay, so for D, which drawing would it be? It'd be the 17th triangle. Or 17th drawing would give me 68 triangles. The last piece of the puzzle we need to add here is how to graph something like this. And in math, when we graph things, this horizontal axis here, left and right, those are our x values. And then up and down are our y values. We assign every point on the grid coordinates, x and y, where x is how far it is to the left and right, and y is how far it is up and down. We need a data table before we start graphing. We did that before. We've already got our data table. Some quick rules for what you need for a graph. It should have a title, and the title should always be your y-axis versus your x-axis. So I'm going to have number of triangles, and then you can put versus, because it's compared to the x-axis, which was drawing number. So generally for a title, we always do whatever our y variable is versus our x variable. You need a title, and it needs to make it meaningful, so it is important that it's set up that way. The other thing, it needs to be done in pencil. That's another one of the points. I'll take off marks if your drawing is not done in pencil. And then what we also need to do is we need to label our axes. So on our x-axis, we had the drawing number. And then our y-axis, which is our responding variable, was our number of triangles. Right? Once we've got our axes labeled, we just need to put down a grid. In my case, unfortunately, it's I've only got a small area to work with here. But what I'm going to do is I'm going to try and make my vertical scale grow by 4. So I'm going to make this one 4, 8, 12, 16, 20, 24. And then for the drawing number, I'm just going to start. Obviously, this point here in the middle is 0, 0. I'm just going to go 1, 2, 3, 4, 6, 7. So my graph will only have up to the 7th drawing. All right, so the first drawing, which would be x is 1, had 4 triangles. So I'm going to go over to 1 and up to 4. That's my first point. My second point is an x of 2 and a y of 8. My third point is an x of 3 and a y of 12. And my last point is 4, 16. Okay? Now, what you can see there is that this is a linear relation. How do you know? Linear means straight line. The word line is in there. So if it's a straight line, it means it's growing at a constant rate. This is a linear relation. This is one example of where we wouldn't want to connect the dots because it's kind of meaningless to have a drawing number of 1.5, right? These drawings grow or they don't. They call it discrete data. It basically means that each data point is kind of standalone. It's meaningless to talk about what's in between. This actually doesn't happen a lot. Most of the stuff we look at in real life, like the height of a plane or the speed of a car or the growth weight of a baby donkey, it's gonna form usually a straight line because there are values in between. In this case it's discrete, so I'm not gonna connect it with a line, but if I did, you can see how it would be linear. Okay, so as a quick summary, if you can take an example or scenario, you can create a table of values. If you can make the equation and check it, assign your variables, if you can use that equation to predict, and lastly, if you can graph, you've got really that's the core of this unit. If you can do those things well, you can probably do the entire unit. We did look at an example here which was on about a medium level difficulty for how you assign the equation. We did look at some more difficult ones in the homework, so make sure that you take a look at more than just one type of equation. And that's it.